Hello and welcome to Group 1's video project 3, where today we are going to be explaining how to complete section 5.4, problem 2. And problem 2 asks us to evaluate the triple integral of the function with respect to x, y, and z for the function f and the region w specified. And it gives us the function with respect to x, y, and z as 42 times x plus y. And we're restricted to region w, which is that z is greater than y but less than x, and y is greater than 0 but less than x, and that x is greater than 0 but less than 1. And so the first step that we should do is to figure out what integral we're going to be working with first. And looking at the regions we are restricted to, what we're going to be looking for is any of them that have constants and any of them that have variables. And ideally, the ones with the constants are going to be further out, that by the time we get to them, we have eliminated most, if not all, the variables, so we can just plug in numbers by that point. Looking here, we have two variables, a constant and a variable, and then two constants. So what we're going to do is we're going to put the x values on the very end of the integral. So we're going to have those on the outside, and then seeing that we have a constant and a variable for y, that's going to most likely be the middle one. And then if we look at z, since they're two variables, we're going to go ahead and work on z first so that we can get rid of the variable z. So what we're going to do is we're going to go ahead and write this out so that the outer integral is going to be those x values. So it's going to be from 0 to 1. And then the middle integrals is going to be 0 to x, because those are the y values. And then the innermost values is going to be from y to x. And just so we don't forget, we have x, y, and then we have z. And then we can go ahead and plug in the function. So it's 42x plus y. And then working inside out, we're using the z function first, and then we're going to do the y function, and then the x integral. So in order to make this easier for us to solve, what we're going to do is we're going to go ahead and multiply this 42 over, so that it's going to be 42x plus 42y. That way we don't have to do any of the product rules or any sort of complicated integration. So that's going to go ahead and allow us to do the integral from 0 to 1, the integral from 0 to x. And then since none of these inner values have z, we can think of them as constants. So that's going to go ahead and give us 42xz plus 42yz. And then we're going to evaluate that from y to x. And then we have dy dx on the outside there. So we're going to go ahead and focus on this inner part right here. So that's going to allow us to evaluate it from 42x. We're going to plug in x first, plus 42yx minus 42xy plus 42yy. Sweet. And going ahead and simplifying this, we get 42x squared plus 42xy minus 42xy minus 42y squared, because we went ahead and distributed this minus sign into there. And the great thing about that is that we can go ahead and cross off these 42 x and y's, because plus and a minus. And so that will allow us to simplify it to 42x squared minus 42y squared. And we're going to be integrating that, going from outside in, from 0 to 1, from 0 to x, dy dx. So go ahead and do this integral now. We're going to see that the first one doesn't have a y, so we're going to treat it as a constant. So it's going to be 42x squared y. And the second one does, and in order to figure that out, y to the 3, because we're going to be adding 1, and then 3 goes into 42 14 times. And then we're going to be evaluating that from 0 to x dx. Again, what we're going to do is we're going to go ahead and focus on this inner part right here. So it's going to be 42x squared x minus 14x cubed. And then we really would be subtracting a 42x squared, but since it's y is equal to 0, we're just going to be subtracting 0 because both have that y value in them, which is nice and easy. So this whole thing goes to 0 here. So it goes to 0 so that we can just focus on this one. So this will give us 42x cubed minus 14x cubed. And seeing as though these are both nothing else other than terms with both x cubed, we can go ahead and simplify this further so that 42 minus 14 gives us 28x cubed. And then we're going to be integrating that from 0 to 1 dx. So this is the nice and easy integer or integral that we are all familiar with. So this is going to be an x to the 4th, and 4 goes into 18 7 times. And we're going to be evaluating 7x to the 4th from 0 to 1. And again, it's really just plugging it in. We only really need to do the first one because the first one's going to give us that 7 times 1 to the 4th, but plugging in that 0, it's going to give us that 7 times 0 to the 4th is going to go straight to 0. And any time 1 is raised to a power, it's going to be 1. So we get that our answer to the integration is 7 units. So that is how to solve question 2 in section 5.5.